So now that you have an idea of what a rational expression is, and I'm just going to show you how you can simplify rational expressions, and it's actually really neat. And all you have to really know is this. Here's your rule. Factor everything. Use parentheses. And cancel out groups. Now I'll explain what I mean by that. There is one other thing I want you to know. If you have a minus b over b minus a, and a does not equal b, because if it did, you get 0 over 0. This always equals, well, I'm going to let you do a quick example. Yes, Benji.
Look at this.
Oh, that's very cool. I see what you're doing. You're going to end up with 2 minus 4 over 4 minus 2, which gives you a negative 2 over a positive 2, which is a negative 1. And the secret here is this. Whenever you have a minus b over b minus a, your value is always going to be negative 1. And I'm just going to write that as a little side rule, because that's a really, really, really useful piece of information. And like I said, the only caveat is a can't equal b, because otherwise you'll get 0 over 0, which does not exist. All right, so let's go ahead and jump on in and do a couple of examples. I'm going to do some pretty basic examples. Let's take a look at n squared minus 49 over 2n plus 14. Well, like I said, the first thing I'm going to do is I'm going to factor everything. And I realize that this is a difference of perfect square, so n minus 7, n plus 7. I'm using parentheses because I have to. And factor out 2 from down here, and I get n plus 7. Now, I'm going to cancel out groups. I'm going to say n plus 7 and n plus 7, and those are canceled out. And so my answer is n minus 7 quantity divided by 2. The reason I want you to see this is because if I had something like this, n plus 5 over n plus 3, you may not cancel out the n's and say, oh, my answer is 5/3. It doesn't work that way. And the reason why is, let's say n was 2, you'd end up with 7/5. Let's say n was 3, you'd end up with 8/6. And 7/5 and 8/6 are not the same thing. All right, so I'm going to do another example. So, like I said, that is not legal. Not legal at all. So that's why I'm erasing it. Let's say I took a look at this example here. A cubed plus 3a squared plus 2a plus 6 over a squared plus 5a plus 6. Once again, I cannot cancel out these 6's. I can't cancel out the a squares. I can't cancel out the a's. I can, however, recognize that this is a group of 4. So if I factor out an a squared, I'm going to be left with a plus 3. And if I factor out a 2, I'm going to be left with a plus 3. Down here, if I factor this out, I'm going to get a plus 2, a plus 3. Now I had to continue my factoring here, and I'm going to get, because it's factored by grouping, a squared plus 2 and a plus 3 over a plus 2 and a plus 3. I can cancel out the same groups, which leaves me with a squared plus 2 over a plus 2. Don't be tempted to factor out an a and then cancel out a plus 2 and a plus 2 and say, oh, my answer is just a. That's it. You cannot do anything else.
Dad?
Yes, Benji?
I made a pyramid.
Oh, you did make a pyramid.
That's cool.
Very cool. And that's it. So, like I said, it's not super hard. You just have to be careful with what you're doing. And I think I probably have enough time to do one more. So maybe I'll just do one more real quick. Let's see if I can find a nice easy one. Let's say
Daddy got 12 equals 1.
9 minus x squared over x minus 3 quantity squared. Well, I recognize that this is
2
a
and 2 is 4.
2 and 2 is 4. And now I'm
Six.
going to write this as x minus 3 times x minus 3. Well, here I have my a minus b over my a plus b minus a. So I can cancel those out. That has become negative, which
2
gives me
equals p equals 1.
negative 3 plus x over x minus 3.
2 and 3 equal x and 1.
If I wanted to distribute this, I'd get a negative x minus 3 over x minus 3. So I can't do anything else. That's it. Hope it was useful.
Whack,
Enjoy.
wacky, whack.